This is section 1.7, part 4, and we're going to look at absolute value inequalities. So prior to this video, we looked at solving absolute value equations. So we're going to do the same thing with absolute value inequalities, and we're also going to graph them. So coming back, I've got a couple of things noted from what we learned in previous videos. This is that and inequalities we know we're going to shade in, and or inequalities we know we're going to shade out. So what does an and inequality look like? Well, there's basically two forms for the and inequality. All right, you're going to look for a problem that either looks like this. So I know these are all letters. So ax, the absolute value of ax plus b is less than c, where a, b, and c are all some number, and x is our variable. Or ax plus b is less than or equal to c. So essentially, we're going to want to make sure that the absolute value bars are isolated on one side of the equation, meaning there's no addition or multiplication on the outside. It's just the absolute value bar on one side of the equation. And so if you have that and then the less than sign, or less than or equal to sign, you know you're going to have the and inequality. So you're automatically going to shade in. It's a nice little shortcut. So or inequalities look very similar, except instead of less than, what do you think there's going to be? It's going to be greater than. So an or inequality, we know we're going to shade out when we see the form ax plus b, the absolute value of ax plus b is greater than c, or the absolute value of ax plus b is greater than or equal to c. When you see this form, all right, you know it's going to be an or inequality, and it's a nice little shortcut, and you can just shade out. So let's look at some examples. All right, so first things first, we've got letter A, and we're going to solve the forms ax plus b is greater than c, and ax plus b is greater than or equal to c. And as I said earlier, we're also going to graph. So we see it's greater than c or greater than or equal to c, so it looks like we have our or inequality. So we should be shading out, and we'll test to make sure that that is actually true. So let's begin. All right, so we know we have an or inequality here. The problem is the absolute value of x minus 1 is greater than 5. So similarly, as we did with the equations, we're going to take the expression inside the absolute value bars, and we're going to set it equal to, well, 5 and also negative 5. All right, but rather than using an equal sign, we're going to make sure we use inequality symbols. So I'm going to take this expression, x minus 1, and we're going to have it's greater than 5. Now we need to use the opposite of 5, which is what? Negative 5. So I'm going to take the same expression inside the absolute value bars, which is x minus 1, and that's less than negative 5. So did you see what happened there? All right, here we've got a greater than symbol. What happened when I made the number 5 negative 5? The inequality symbol flipped. So that's a nice little note. All right, so whenever you change a number from positive to negative using inequality symbols, you have to make sure you flip that inequality symbol. So we're going to flip the inequality symbol when you change 5 to negative 5. All right, so now you're going to take each inequality and solve them independently from each other. So simply going to add 1 to both sides to get x alone, and we see x is greater than 6. Add 1 to both sides here, and we see x is less than negative 4. Alright, so we have two parts to our answer. We know it's an OR, so it's going to be one answer or the other. So we do want to graph these. So I've got my number line. These are quite far apart from each other, so rather than just having 5 tick marks, I would need 10. So in this instance, I am just going to take a little shortcut and actually just use 2 tick marks. Alright, one for each number. So I'm going to have negative 4 over here and 6 over here. You want to make sure the larger numbers are always on the right, smaller numbers are always on the left. So we see x is greater than 6. So open circle, because it's not greater than or equal to. And x is greater than 6. I want to make sure 7, 8, 9, those are all greater, so I'm going to shade in this direction. And I also see x is less than 4, negative 4. So open circle at negative 4, all numbers less than negative 4, so that would be negative 5, negative 6, negative 7. So that's in this direction. So you can see how did we shade? We had an OR inequality, and we ended up shading out. Alright, so are we correct? Well, simply just pick a number, alright, in the shaded region. So 7 is larger than 6, so I'm going to plug 7 in here. Is 7 greater than 6? It is, so I know I've done this part of the problem correct. And now I need to pick a number less than negative 4, so I'll pick negative 5. Is negative 5 less than negative 4? And it is. So I know I've done both parts correct, and I feel safe moving on. All right, let's look at one more of these. All right, so we'll go down to number 2. And we have the absolute value of 3x plus 4 is greater than or equal to 10. So I'm going to take the expression inside the absolute value bars, which is 3x plus 4, and it's greater than or equal to 10. Sign doesn't change because I kept this number positive. Now I'm going to take the same expression 3x plus 4, and I need to make 10 negative. So what's going to happen to my inequality symbol? It's going to flip directions. And now I have less than or equal to 10. So now I'm going to go ahead and solve each of these inequalities. So I'm going to subtract 4 from each side. And I've got 3x is greater than or equal to 6. Divide both sides by 3. 3's cancel. And I see x is greater than or equal to 2. Subtract 4 from each side in this inequality. And I've got 3x is less than or equal to 6. Right? And then I have, is that correct? Oh, no, I'm sorry. Look what I did. I didn't make this negative 10. So I'm going to backtrack a little bit. I set this side equal to positive 10. This side should have been set equal to negative 10, and that's why the inequality symbol flipped. So I've got negative 10 minus 4 is going to be negative 14. So I'm going to divide both sides by 3. And I see x is less than or equal to. 3 does not go into 14 evenly, so I'm going to keep it as a fraction, negative 14 thirds. So I've got two parts to my answer. We know we have an OR inequality because the original problem was the absolute value greater than or equal to, and then it was 10. So last thing I need to do is graph. So I have negative 14 thirds over here and positive 2. Negative 14 thirds, I'm going to fill in my circle because it's less than or equal to all numbers less than negative 14 thirds, so that's to the left there. All the numbers get smaller in this direction, get larger in this direction. So again, filled in circle because it's greater than or equal to. And I need all numbers greater than 2 because x is greater than or equal to 2. And again, you can see with the OR inequality, we've shaded out. So we're going to move on now to part B, and we're going to look at solving and graphing and inequalities. So we're going to solve the absolute value of ax plus b is less than c, and the absolute value of ax plus b is less than or equal to c. And again, we're going to graph. Okay, so the first problem is the absolute value of 1/2 x minus 3 is less than or equal to 5. So I'm going to take this expression inside the absolute value bars, 1/2 x minus 3, and that's less than or equal to 5. I did not change the sign. Take that same expression, 1/2 x minus 3, and I'm going to flip the inequality symbol because I'm changing 5 to -5, and I made sure to put the negative there this time. So, solve each inequality. I'm going to add 3 to both sides here. The 3's cancel, and I get 1/2 x is less than or equal to 5 plus 3. Well, that gives me 8. Now I've got 1/2. I want to detach it from x, so I'm going to multiply by the reciprocal. The reciprocal of 1/2 is 2. So I'm multiplying both sides by 2. So 2 and 1/2 cancel, and I get x is less than or equal to 16. I'm going to go over here and solve this inequality, so I'm going to add 3 to both sides. 3's cancel. I get 1/2 x is greater than or equal to -5 plus 3 is -2. Again, multiply both sides by the reciprocal of 1/2, which is 2. The 2 and the 1/2 cancel, and I get x is greater than or equal to -4. So, we want to graph. Looks like we have an and inequality because it's less than or equal to, so I expect us to be shading in. We'll see if that happens. So I've got -4 over here and 16 over here. We know it's less than or equal to 16, so we have a closed circle, and we want to shade it. X is less than or equal to 16, so all numbers less than 16, which is in this direction. All numbers greater than or equal to -4, so greater than or equal to, which is in this direction. So I've shaded. And then I'm going to finally, technically this is alright, but remember and inequalities are written as one piece. We don't write the word and, so you're always going to put the smaller number first, which is -4. Alright, and this inequality symbol opens up away from -4. So it's opening up towards x. And now I can see, here's the x. I only need to write the x once. It's opening up away from x and 16. And you'll notice with your inequalities, your and inequalities, these will always be facing the same way and to the left. Alright, they'll be kind of pointing to the left. So this is how you should write your final answer, and this is what your graph should look like. Alright, and, well, I guess we should check. Alright, so we'll just do a quick check mathematically. Alright, we'll say, okay, 16, alright, we want to pick some number in between here. So what's a nice number to pick between -4 and 16? I would say 0. So you can come on up and see if 0 works in each of the cases. Alright, so if you were to plug 0 in, sorry, I'm scrolling up. Okay. Plug in 0, half of 0 is 0. 0 minus 3 is -3. What's the absolute value of -3? +3. Is +3 less than or equal to 5? And it is. And we can go over some checks in class as well.